amount of warning time you can expect is 6 or 7 seconds.
As big as a 15 megaton city killer nuclear bomb.
If we ever announce that there is one that's going to hit, and we don't have an answer to what are you going to do about it, you're going to have public panic.
It's only a matter of time before the next big one hits us.
The technology is available today so that when the Earth is in fact threatened by an asteroid, we can move it out of the way so that it doesn't hit the Earth.
Checking out traffic this morning along the Gardner, Guy Valentine.
It's a bit of a battle for drivers without cover. I'm talking if you don't have any shade, because you're fighting some pretty bright sunshine.
And also caution on Highway 7 going eastbound.
And northbound Don Valley Parkway on the ramp to eastbound 401, we've got a disabled vehicle.
June the 14th, 2002. It was just another busy workday with all the usual hustle and congestion. With all the close calls and near misses that people all over the world have come to accept as the normal level of risk in everyday life. But on that day, high overhead and behind the sun, what no one saw coming, what no telescope on Earth was able to see against the blinding light, was an asteroid big enough to destroy an entire city. From behind the sun, asteroid 2002 MN came hurtling towards Earth, faster than a speeding bullet. It shot past, less than a third the distance to the moon, and nobody saw it, until 3 days later, when the rock emerged from Earth's shadow into the night sky, going away.
It looks like the Earth just dodged a bullet. Actually, it was an asteroid. Scientists say it blew by last week at a distance they describe as a close shave.
The airline industry would call this a near miss. Scientists who study asteroids and comets called it a problem.
The threat of asteroid impacts on the Earth is very real. We know that throughout history this has happened. The craters we see on the moon are examples of the kind of impact history that the Earth has had. But it also happens very rarely. So it's a very unusual kind of hazard. It's a hazard in which the risk in any one year is very low, but it does happen, and if it really did come about on our watch, it could end civilization.
These cosmic bullets originate on the far side of Mars, in the main asteroid belt, where a bracelet of celestial debris circles the sun. Millions of rocky fragments, building blocks of a planet that never quite came together when the solar system was formed. What's often depicted as a busy cosmic junkyard is actually more like a big empty speedway. The rocks are far apart and moving very fast, ranging in size from pebbles to boulders to rocks the size of Mount Everest. Occasionally, the tug of Jupiter's enormous gravity drags an asteroid off course, causing it to crash into another asteroid. Some veer away into new orbits that cross the paths of Mars, Earth, Venus or Mercury. Another ring of debris called the Oort cloud is the source of most comets, which are big, rocky ice balls that orbit the sun and cross the paths of the inner planets. All the inner planets and our moon bear the scars of numerous asteroid and comet impacts.
We do get hit all the time by pieces of debris from asteroids and comets. In fact, 40,000 tons of cosmic debris plummets into the atmosphere every year. We see them every night as shooting stars. They don't hit the Earth very often, but when they do, clearly it isn't just going to be a matter of a shooting star seen in the sky. So it is inevitable. It's only a matter of time before the next big one hits us.
Even small rocks can make a big impression. In 1908, about 2,000 square kilometers of Siberian forest were instantly flattened as an asteroid exploded near the Tunguska River. The impact site was so remote, researchers had to mount a wilderness expedition just to find the place. When they arrived, there was no crater. Paintings, based on eyewitness accounts, described a fireball. A horrendous explosion in the sky.
Didn't actually come crashing down to the ground. It exploded maybe 5 to 10 kilometers up in the atmosphere, and that made a big blast wave in the atmosphere, and that is what did the damage.
All this was caused by a relatively small asteroid, somewhere between 50 and 100 meters across. Roughly the same size as asteroid 2002 MN, the one we couldn't see coming. Tunguska's 2,000 square kilometer blast wave would have leveled London. But as bleak as the thought of cosmic collision may be, there is at least a glimmer of hope.
One of the special things about the asteroid impact problem is that unlike the weather or earthquakes or other natural hazards, we, at least in principle, we could do something about it.
And when we know one's coming for us, our claim is that the technology is available today to stop it.
On the Earth, we've got active geology, we've got volcanoes, we've got earthquakes, we've got continental drift, we've got rain, we've got wind, we've got storms, we've got snow. All of those things erode away craters, and that, in some ways, actually fools us into thinking that indeed the Earth doesn't get hit as often as it actually does.
Counting craters on the moon and then estimating how often the Earth gets hit can be a pretty sobering exercise. One scientist who made that kind of calculation was astronomer Ernst Opic, who published his impact estimate back in 1951. The general public, however, paid little attention to the science or the implications. But one individual who did take the issue to heart was Lembit Opic, the astronomer's grandson, who got himself elected to Parliament.
My grandfather is the reason why I carried on in politics, what he initiated in science. In essence, he was a pioneer. He saw the danger of asteroid and cometary impacts with the Earth, and he had the courage to speak up about them. And he did that at a time when it wasn't really taken seriously, in the 1950s and 1960s.
After years of pushing and prodding, Lembit Opic convinced the British government to commission a comprehensive scientific study of the asteroid and comet threat. The expert conclusion was, the threat is indeed real.
Now, the government has set up a task force to examine the risk of an asteroid hitting the Earth.
Still, skeptical politicians might want to get on the bus and take a trip to the Natural History Museum. Ask any schoolchild who's been there recently, and you'll hear a fascinating and truly scary tale about what happened to the dinosaurs.
The dinosaurs were alive here. They were dead when this sediment was deposited, and this layer is one of the most unique layers in Earth history.
In 1980, the discovery of iridium beside a layer of clay which marked the end of the age of dinosaurs led Lewis and Walter Alvarez to publish a theory that a huge asteroid or comet had hit the Earth 65 million years ago and wiped out the dinosaurs. But for this concept to be confirmed, there had to be a crater. There may be tons of dinosaur bones in these dry canyons, but where on earth was the big crater? Just the kind of mystery a budding young scientist would love to solve.
When I went back to...
Off the coast of Mexico's Yucatan Peninsula, Dr. Alan Hildebrand investigated a huge gravity anomaly discovered by oil drillers back in the 1950s. Put that together with a semicircular magnetic anomaly, and you get a massive crater, 180 kilometers across, near a little village called Chicxulub Pueblo. Most of the crater is underwater now. Erosion and continental drift have covered the visible evidence. But 65 million years ago, This was ground zero.
This object would have fallen through the atmosphere in just a few seconds. Just going through the sky, it would have been brighter than the sun. As soon as it contacts the surface of the shallow sea and Chicxulub, of course, it starts propagating the shock wave down into the planet, and it keeps pushing into the planet, and it only gets stopped maybe about 30 kilometers down. The pressure wave would have traveled around the entire planet in the atmosphere. You could have heard the impact on the other side of the planet. The giant impact fireball rising out of the hole, it would have risen, say, 10,000 kilometers above the surface of the planet. Near the impact site, it would have been so hot, it would have evaporated the clouds and been hot enough to make the forest, even a green forest, begin to burn.
For Alan Hildebrand, finding that crater pretty much clinched the argument. Planet Earth had been all but sterilized by a rock the size of Mount Everest.
3/4 of the species of large animal life went extinct.
We have made the case. We've got the qualitative information and we've got the statistics to show that there is a very serious risk.
If you wanted to save planet Earth from cosmic disaster, where would you find people with all the right stuff to do the job? Well, Houston, Texas might be a good place to start looking. This town has that rarest of breeds, the space cowboy. Houston is home to NASA's Johnson Space Center, where rocket science is a way of life and astronauts learn their trade.
If you could roll me 90 and then go down, I'll come in on my side.
Behind a swimming pool big enough to swallow an apartment block, you'll find a small research lab where the rocket engine of the future is being built and bench tested.
Yeah. Very nice. The question is, how big is the plasma going to go from here to here?
Dr. Franklin Chang Diaz is one of the lead researchers, as well as an astronaut with 7 shuttle missions under his belt.
And in fact, there was a time in one of my flights where we got hit by very tiny micro meteorites, perhaps, or some sort of orbital debris, which made little tiny dents or little craters in the windows of the shuttle.
Well, that tube is welded. Yeah, I did it. You already welded it. Yeah, I did it.
First-hand experience with rocks in space gave birth to a new idea and a dual purpose to Chang Diaz's work here. His rocket engine has been developed for long-distance missions to Mars, or as far away as the icy moons of Jupiter. But it could also be used to push a dangerous asteroid out of harm's way.
I am concerned enough to think that we need to not waste time arguing about it as to whether it's real or not, and do the demonstration. Because even if this is a threat which has a very low probability, all it takes is one, and we are history.
But before we can send a spacecraft chasing after a rogue asteroid, we have to know where to look for it. In the American West, if you drive across the desert to the White Sands Missile Range in southern New Mexico, you'll find the most powerful and effective asteroid hunter on Earth. Scientists here have tested everything from rockets to the very first atomic bomb. Today, across the valley floor from the Trinity bomb site, the US Air Force has installed one of the world's most advanced telescopes. This state-of-the-art technology was developed by MIT's Lincoln Laboratory as part of the Star Wars anti-missile defense system. These may not be the world's biggest telescopes, but they clearly are the best when it comes to finding deadly rocks in space. This is Linear, the Lincoln Near-Earth Asteroid Research Facility.
On a given night, when we scan the sky with this, we'll find perhaps 10 to 12,000 moving objects in the sky. Now, most of those are main belt asteroids, and as such don't represent any danger to Earth. But on the other hand, something like half of those will be brand new discoveries, and buried in there will be 1 or 2 near-Earth objects.
Because the Earth rotates, the sky is always moving overhead. To get a clear picture of an asteroid, you have to make the sky stop moving. And you do that with a telescope that can track or follow the stars. This way, you can take time-lapse pictures that isolate the blur of fast-moving asteroids against a crystal-clear sky. It then records these pictures like a TV camera on a computer chip that has 20 times more detail than the picture you're now watching. The linear computer deletes previously known stars and planets, leaving a less cluttered time-lapse sequence of the new discoveries. At the end of each night shift, Linear's thousands of new discoveries are emailed to the International Astronomical Union's Minor Planet Center at Harvard University. A team of only 3 scientists must cope with the avalanche of new sightings, searching for potentially hazardous asteroids or comets. Computers make a rough calculation of an asteroid's orbit, but it's up to Brian Marsden to estimate the level of risk.
They may be reporting 50 or 60,000 observations from one night, and it takes a while to get through that. But so we look first at the fast movers and see if there's anything interesting there. H is equal to sine delta. We do sometimes get close to 70 or 80,000 observations a day, almost 1 per second. There are some days when we effectively have 1 observation per second.
Even with fast computers, Marsden's team can make only a preliminary calculation of each asteroid's orbit. 5 shots in one night cover only a tiny segment of an asteroid's orbital path.
You can't solve for the orbit completely from that, but the fact that you're seeing motion over a half an hour or an hour, something like that, does allow us to get a partial solution for the orbit.
Refining the orbit gets complicated. When 2002 MN shot past, its trajectory was warped by Earth gravity, and scientists at NASA's Jet Propulsion Laboratory in Pasadena, California, had to add that to their calculations.
Here's an animation I put together of the asteroid last year, which was discovered after it passed by the Earth.
An elite team of mathematicians and celestial mechanics is now working full-time on a computerized warning system.
Our orbit animation, you can see how when it returns out to the asteroid belt, the close approach to the Earth has changed its orbit, and it's no longer returning to the same place it started.
Because 2002 MN will circle around the Sun and come past us again, the NASA Orbital Mechanics team will have to adjust the calculation in order to know whether it will ever pose a danger to Earth at some point in the future.
So here we've zoomed in on the Earth-Moon system and we're looking down. You can see how close it came to the Earth that went over the top, and how you can actually even see the bend in the trajectory. So it's a great example of how a close approach to the Earth, or in fact any planet, can be used to, or can significantly change in orbit.
To know where an asteroid is likely to be in the future, you need a model of the solar system. Mechanical models that show the relative motions of the Sun and planets have been around since the early 18th century. They're called orreries. What the celestial mechanics at NASA had to do was create a new digital model. One that includes the gravitational attractions of all the planets and the sun, and all the other forces that can affect where an asteroid might go.
You just compute what forces are acting on this particular asteroid from all the planets and many of the minor planets in the solar system, and then we can actually trace the motion of that object around the solar system for hundreds of years.
For scientists, the acid test of their mathematics came when a strange new comet raced toward Jupiter. A stream of cosmic bullets that would shock and amaze me. In the spring of 1993, the eyes of the world turned almost in unison towards a Doomsday Rock like no other. From the far side of the solar system, it flew in a death spiral toward the largest planet. Gene Schumacher, his wife Carolyn, and their colleague David Levy had discovered an odd-looking streak of light that turned out to be a fractured comet. 21 large chunks of icy rock and cosmic dust heading towards Jupiter.
We knew we had something very unusual. It was so unusual we were a little unsure just what we were dealing with.
NASA asked Paul Chodas and his team to calculate the orbit and predict whether this new comet would actually hit Jupiter.
And it started off at some 60%, and before long it was 90%, and this was a year before impacts. As the impacts approached, we continued to predict not just the impact probability, which went very high, but where and when the comet fragments would hit the planet. And it was a prediction months in advance, and as we got closer and closer to the impacts, I kept wondering, well, is the math right? Will this actually happen the way it was predicted?
A giant comet is on a collision course with Jupiter.
Everybody on Earth who was paying any attention wanted to see if the comet would actually hit Jupiter.
We have liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
NASA's Hubble Space Telescope set its sights on the planet, and the pictures of what happened next were truly stunning.
Right there! Oh! Get it! Wait. Oh,
And then the impacts occurred. We were within minutes of getting the right answer on the time of impact, and the location of impact turned out to be just right.
Over the next week, 20 more fragments of the comet crashed into Jupiter, some leaving scars as large as the Earth.
Bang on its cosmic schedule, the comet's first impact was recorded by NASA within the last hour.
When fragment G slammed into Jupiter, releasing an amount of energy equivalent to about 6 million megatons of TNT.
In the wake of SL9, a group of concerned scientists gathered in Italy for a brainstorming session. They created a brand new international organization called the Space Guard Foundation.
Okay, I'm going to join.
To promote the discovery and study of near-Earth objects.
Some people imagine that there are lots of astronomers out there scanning the sky looking for incoming comets and asteroids, and that, of course, is not true. In fact, until recently, there was hardly anyone out there looking.
It's going to glow for about a half an hour and set everything on fire around you.
But whose job is it to defend planet Earth? Weapons scientists from the United States and Russia had already held a series of meetings and came up with their own ideas about how to deal with the impact threat.
You blow off some material, you get a reaction in this perpendicular direction.
The military establishment
under Star Wars, had created a whole lot of devices, or at least concepts, for weapons in space and devices in space. And in the early 90s, when the Star Wars program was looking a little bit iffy, I think there was some motivation for them to try to apply their technology to this newly discovered hazard from asteroids and comets.
The military approach to the problem proved to be controversial. The notion of sending nuclear weapons into space generated an immediate backlash.
Edward Teller was proposing that we blow up an asteroid to show that we could protect the Earth, and I thought that was a pretty crazy idea. Blowing up an asteroid with a big bomb has a lot of problems associated with it, violating treaties, taking a single asteroid and making a swarm of smaller asteroids. It seemed like it was more interest in bombs than it was a serious interest in defending the planet. For NASA, on the other hand, NASA obviously is the natural agency to discover the threat and the objects, but they say no, planetary defense, that's a military obligation and not an obligation of NASA.
Not NASA, not the military. Just when it seemed planetary defense was nobody's job, a tiny speck in the sky would set off doomsday alarms around the world. On a winter's night, the 6th of December 1997, a dim streak of light moving through the constellation Cancer was captured by a telescope in the Arizona desert. Big enough to destroy civilization as we know it, asteroid 1997 XF11 seemed to be heading towards Earth. The initial sighting by the Kitt Peak Observatory in Tucson, Arizona, was relayed to the Minor Planet Center at Harvard University in Cambridge, where a computer made the first rough calculation of the orbit. They were pretty sure it would miss the Earth on this pass, but it would be coming round again, and it looked like there could be a problem in 30 years.
There were indications of close approach to the Earth in 2028. That was about 45,000 kilometers, which really was rather close.
With only a handful of sightings, the orbit calculation remained very rough. It was hard to tell where this rock was going. So Brian Marsden posted a bulletin asking astronomers around the world for more observations before the rock became too faint to see.
I was saying, hey, get your big telescopes onto this. On the one hand, we're only going to be able to observe it for another month or so. We want to improve the orbit calculation and find out exactly how close it is coming.
But one line in the bulletin said that the chance of a collision was small, but it was not entirely out of the question. Within hours of the website posting, reporters discovered XF11, and doomsday headlines screamed around the world. Because the close approach in 2028 would put the asteroid nearest to Europe, London newspapers focused on the exact moment life on Earth might possibly end.
Pictures of it on the internet show it as a tiny moving blob. Scientists have calculated its path in the year 2028.
Watch very carefully. September, October the 28th, the two coalesce.
But at NASA's Jet Propulsion Laboratory in California, the orbital dynamics team thought there must be some mistake.
To my great surprise, when we ran our software, it said that the probability of impact of this particular asteroid in 30 years was essentially zero.
As it turned out, the end-of-the-world asteroid would miss the Earth. That big rock in space posed no threat after all. A frantic hunt through the archives at NASA had turned up photographs of XF11 taken 8 years earlier.
And as soon as those were placed into the orbit determination process, they confirmed the fact that there was no chance that it could hit the Earth in 30 years.
The public at large was not understanding uncertainty in this. They wanted an immediate answer. Is it going to hit us or not?
But people were paying attention. One side effect of the false alarm was that public and political awareness of the threat had been raised. 2 months after XF-11, new hearings were held in Washington and NASA was told to speed up the science of asteroid detection. Finally, it seemed, there was a political will to do something. Congress gave NASA a 10-year deadline to search the skies and get a fix on the largest of the Doomsday Rocks. They called it the Space Guard Survey. While astronomers geared up to search the skies, Hollywood was going into overdrive.
I would go to every dinner party and I would say, are you aware what would happen if a comet was actually on a collision course with the Earth?
Oscar-winning screenwriter Bruce Joel Rubin was hard at work on the remake of a sci-fi classic. The new film, called Deep Impact, would be a Steven Spielberg production.
High on a mountaintop, an army of scientists work desperately to build this giant rocket, this modern Noah's Ark to carry a few picked survivors of our doomed civilization.
I think the thing that was hardest for me was the realization that people would have to be chosen to survive.
Let's take the ship away from them! Come on!
Probably a very, very small percentage of human beings would be left on the Earth able to survive something of the intensity of the comet that hit and destroyed the dinosaurs. So I felt making this movie is not just a mission to tell a good story, it's to change minds. It's to let people go, this is something real. This can happen to us. This movie is a wake-up call. It's not just a Hollywood movie, it is pointing at you.
As Hollywood released Deep Impact, telling the world in no uncertain terms that cosmic collisions were no longer just a cosmic joke, real-life professional asteroid hunters were making movies of their own. But instead of using cameras, they worked with delayed Doppler radar. Take the same technology behind a police radar system, jump the power to 400,000 watts, and you've got NASA's Deep Space Network, with huge multi-dish systems, like the Goldstone tracking station in California's Mojave Desert.
This is the main room of the pedestal of DSS-14.
The first time radar astronomer Stephen Ostro bounced a signal off a rock in space, a wobbling blot of pixelated data bounced back. What looks like digital gibberish spoke volumes to Steve Ostro.
Radar really does three things at once. One, it works at long wavelengths, so you're sensitive to structure on large scales and metal concentration. The other is you can make pictures. And you can't do this from the ground in any other way. You make pictures of objects, and then we take a sequence of pictures, and we go through a computational process to produce the 3D models. That's the second thing. The third thing is that it makes very precise measurements of distance and speed.
When the 1,000-foot radar dish at Arecibo in Puerto Rico bounced a beam off an asteroid called Castalia, the data was translated into a 3D computer model. The very first radar movie showed how Castalia spins and revealed that it was actually two massive chunks of rock held together by weak gravity. Every time they made the trip to Goldstone for a new radar target, Ostro and his team were like kids reaching into a box of chocolates. They never really knew just what they would find. Asteroid Cleopatra, shaped like a dog bone, was roughly the same size as the state of New Jersey and was made almost entirely of metal. Echoes from asteroid Tutatis produced images of a rocky, cratered surface and a wobbling, tumbling spin.
Every single one of these objects that we've made a shape model of is very different. This is Tutatis.
From a telescopic smudge of light to a 3D shape model, radar gave them physical details and the first clear idea of what asteroids are really like. In the year 2000, the radar movie crew developed a dark and mysterious new image, asteroid 1950 DA, a big rock that gave everybody a bit of a shock.
Once we got the radar data, we began the normal process of just seeing how far in the future we could predict this thing before the uncertainties in the orbit blur out. And in this case, we could go over 880 years into the future. And what was startling about that case was the impact probability turned out to be non-zero.
Non-zero means there is a chance this rock could hit us. On March the 16th, in the year 2880, 1950 DA will cross the Earth's orbit. Will it hit us? The odds, 1 in 300. If 1950 DA does hit the Earth, the most likely point of impact would be at sea. Of all the big asteroids discovered thus far, this is the most dangerous one we know. Eric Asfaug and Stephen Ward have created a computer model of the impact.
Yeah, it's kind of funny how this started. It was with the movie Deep Impact, and I was getting phone calls. Lots of people were getting phone calls about the movie, whether it was accurate, the big cresting tsunami coming across.
The concept here is that this asteroid, which is about 1 kilometer across, will hit the ocean at 17,000 miles per hour, and it'll blow a hole in the ocean about 19 kilometers across and all the way to the bottom. And so when this huge hole of water gets blown into the ocean, the water will run back in again, and it overshoots and then collapses and overshoots many, many times, and each time it pumps out a wave. So it starts out hundreds of meters high, comes ashore on the coast of North America at about 50, 60 meters. Up toward Canada, Grand Banks, it's about 40 meters. 20 meters here in the coast of South America, and about 15, 20 meters all the way over to Europe. These waves would run inland about 4 kilometers. So pretty much everything within 4 kilometers from the beach would be covered up repeatedly. And so we'd pretty much be wiped away like you're scrubbing the floor, you know, just scrub like this, and it's pretty much we'd all be carried back out.
In February 2001, a NASA spacecraft called Near Schumacher made the first ever landing on a chunky, pockmarked rock named after the Greek god of love. Asteroid 433 Eros is 33 kilometers long and 13 kilometers wide, one of the largest near-Earth asteroids. The pictures were spectacular. The data will take years to process. Proving that they could land on an asteroid was a major achievement, but in the end, they still don't know much about what's inside. How dense? How tough? How brittle or crumbly is it? What would happen if they gave it a good shove? The surface appearance of any dark and mysterious object can be very deceiving.
So these two spheres, as far as I can tell, have exactly the same mass, the same compressibility, the same color. If I were a spacecraft orbiting these and these were asteroids, I'd be very hard-pressed to tell which was which. Yet, if I dropped them from a height, and only one of them bounces, really illustrates the fact that one of these responds elastically and one of these responds like a lump of clay. And it's critical to really go and find out what's inside before we even start thinking about moving these things around.
When a 3D model of the asteroid Castellier got smacked in a computer simulation, a problem occurred. An impact with the same energy as the Hiroshima bomb turned Castellier into a pile of rubble, but did not deflect its trajectory in any significant way. But there are other ways to apply force to deflecting an incoming asteroid. Using the power of the sun to push dangerous rocks out of the way may not be so far-fetched after all.
This is a typical near-Earth asteroid. Its name is Galevka. It's about 1/2 kilometer across. It's a hazardous asteroid. Its most likely fate is going to be to strike the Earth someday, thousands of years from now.
Modern-day researchers like Eric Asfaug say the idea of a giant orbital magnifying glass to burn space rocks could work.
You create a vapor plume in one direction, and that starts the asteroid moving in the other. It's a very gradual process. It's not going to happen instantaneously. You need to know where this guy is 100 years or 50 years ahead of time. But if you do, you've got all the time in the world for a satellite to sit there, no human intervention whatsoever, and it'll gradually shove the asteroid into a different orbit and it'll miss the Earth.
Some of the technology to do this already exists. Take an inflatable parabolic antenna the size of a tennis court, convert it to a solar collector, and use it to focus sunlight on an asteroid. The Russians have built and are testing a giant sail that captures the minute pressure of sunlight. Just attach the sail to an asteroid and let the rock hitch a ride to someplace else. But using the sun to save the Earth means waiting for nature to do the work. If we don't see an asteroid until the last minute, solar power would be too little, too late. A nuclear electric plasma engine could push an asteroid out of harm's way. The rocket technology at this NASA lab in Houston, Texas, could provide the power for a space tugboat. A group of astronauts and aerospace engineers is designing the B612 mission to prove that asteroid deflection can be done with existing technology.
These are rockets that have very tiny amounts of thrust, but they are so frugal in the use of propellant that we can keep the rocket going for periods of the orders of a year.
Building a better rocket engine is only the first step. Figuring out how to latch on to an asteroid, point it in the right direction, and push without losing control is the really tricky part. After years of research, NASA finally had it, the first complete draft of a plan, a demonstration mission, to save the planet.
We can move the asteroid off the impact with the Earth 10 years later so that it misses the Earth, and not just miss it randomly, but miss it very precisely so that we don't simply pass on the problem to our grandchildren.
Midway through 2003, the Space Guard survey had reached the halfway point. A little more than half of the kilometer-sized near-Earth asteroids had been located, and the news was mostly good.
For the 60% that we have already found, I can tell you that there is not a single one that poses a danger. For the 40% that we have not yet found, I can tell you nothing. One could hit tomorrow. Not very likely, but until we've found them and cataloged them, we won't know.
But finding the really big asteroids, those 1-kilometer monster rocks capable of ending human civilization, is only the first part of the challenge. There are an estimated 50,000 smaller asteroids that are big enough to cause tidal waves or destroy vast regions of the Earth.
A 200-meter asteroid happens maybe once every 10,000 years, but that's like 600 megatons to 800 megatons exploding in one place.
Recall the small 60-meter rock that exploded over Siberia in 1908? Well, even though it could have destroyed a city like London or New York, rocks that small are not included in the current Space Guard survey, meaning no one is officially looking for them.
Which, of course, is the same thing as saying that chances are enormous that a Tunguska-sized object will find us before we even see it coming, as happened in 1908. That is likely to happen nowadays, that we won't see it coming.
There has been talk of expanding the search to include smaller asteroids. It'll take more and bigger telescopes and, of course, more money. But until we do, we'll have no idea where those city-killer rocks are.
Evolution on Earth has proceeded in part because every so often a global catastrophe comes along, pushes the reset button, and new things happen.
It wiped out the dinosaurs 65 million years ago, and at the time, we mammals were just furry little creatures burrowing around in the ground, and an asteroid or a comet impact took out our principal competition.
I guess we are saying implicitly, if not explicitly, that we want to do away with that natural cycle.
We've had enough evolution. We like ourselves on the top of the ladder. And we can do something which will change cosmic evolution from this point forward in terms of life on Earth.
Dinosaurs ruled the Earth until a big rock wiped them out. The question is, will another rock do the same to humanity?
Let's get a couple good pictures here.
Humans are the first species with the potential to block a doomsday rock and switch off the evolutionary reset button.
People very often say, look, you're just a doomsayer. You think that these awful things are going to happen. I'm not that way at all. I'm entirely optimistic. The way in which I view asteroids and comets and the possibility of them hitting the Earth is that it's a great challenge. Thank goodness we've realized the hazard and the danger before the next one happens. It's given us time, we hope, to do something about it.
Scientists can study the sky and find the dangerous rocks ahead of time. Astronomers can do the math and predict the orbits. People have the desire and the right stuff to do the job. There's a whole new field of science that could give humanity an option the dinosaurs never had.
They're sleek, they're cutting edge, they're top secret, and they're worth millions of dollars each.
It's a beauty. I'll take two.
They're concept cars. And before you can hop into your SUV or travel in your sports coupe across country, your vehicle starts here as an over-the-top prototype that can make even the most difficult-to-please consumer drool.
That car is hot, very hot.
Auto manufacturers spend fortunes to grab your attention and hold it. And with everything from the powerhouses of the future to the zero-emissions vehicles of the next generation and some of the wildest things to ever roll on four wheels, you're gonna travel to places you never thought possible as we take you behind the scenes and behind the wheel of the world's most extraordinary concept cars.
Design and sculpting and art and mixing with technology in a fun new way.
I come to see what's happening in the future.
Every year, auto manufacturers unveil the latest models of sports cars, sport utility vehicles, hybrids, trucks, even motorcycles. Right here.
They're all over the world. Japan uses car shows for the same reason.
and so do the Germans and the Swedish and the English and the Italians. It's a great way of finding out what the public likes.
It's beautiful.
We'll see. I don't know. I may have to work a second job, but we'll see.
Second, third, who cares?
And if you travel to an auto show, you'll see it's like a debutante's ball for some of the newest designs and most advanced automotive technology. They're also where car designers reveal to the world incredible ideas for the future.
When we roll out a new concept, it's very much like opening night for a movie.
We expose them at various auto shows around the world where we have our toughest critics, the journalists, the buying publics, and our fellow designers.
Where else can you take a peek at concept dream machines like the super chic Mercury Messenger or the Chevrolet SS Concept that looks like a modern-day hot rod? You might be asking yourself, where can you buy one of these tricked-out fantasy cars? The answer? Nowhere. But why would an auto manufacturer spend tens of millions of dollars to build something they'll never sell?
Why do we build concepts? Well, that's a good question. One, because they're fun. And we need to test ideas, to ourselves, the engineering value, can we come up with something new and make it better? But we also need to test the ideas to the public.
They're trying to find out what the public, the people that are buying their cars and trucks, think about the concept. Does it make sense? Do we really think the public is going to embrace this new concept?
It's this huge experimental test to kind of get an idea for what people want, what they like.
That's pretty, I like it.
And concept cars cover just about every emotion. You never want to stop smiling while you're traveling? Then take a look at one of the craziest concepts straight from Japan. If you think it looks like a box, that's because it is.
Right now, there's a trend among Toyota and Honda for coming out with boxes, coming out with cubes. It's kind of hop in this thing and bring all your stuff with you.
If you're concerned that your next car might have too many blind spots, open your eyes wide. Almost every inch of this concept car is a window. It's designed for urban driving, small, electric powered. And when you finally get that hard-to-find parking space, just unload your very own scooter to make getting around town quick and easy. And if you're wondering, when is this vehicle going to be put on the market? Let's just say your grandchildren might be lucky to take their driver's test in this thing. This car may look strange, but it's a bold statement in a whole new era of innovation.
You're seeing Japanese cars that are starting to look Japanese. They're just saying, hey, this is what they're going to look like. If you don't like it, tough.
Talk about taking chances. How about a car that not only interacts with you, but has emotion too? Meet the Toyota Pod. You steer it with a joystick, just like a video game. See that poking out the back? It's not an antenna, it's a tail. And when you start it up, it wags to show you it's ready to go. Running out of gas, the car's exterior lights turn blue. Fill it up. Golden. And with personalized interactive GPS, you're gonna feel more like you're walking your dog than driving a cold piece of steel. These are cute, fun, but who would want to buy them? And why?
The jury's still out. We don't know whether young people are going to want inexpensive cars that have a certain style and function, or style and pizzazz, versus the boxes that are being designed now that are pure function. And it's going to take a while to find out.
A lot of times, despite your best intentions as a car maker, the public looks at it and goes, are you kidding me?
So whether you love it or you think it's just plain weird, almost every concept car is going to make you take notice. And that's exactly what car makers want.
We got to throw down the gauntlet. If we're going to be different, we're going to be different. And we're going to have to show the world that we mean business.
And that risk-taking is ultimately about making an auto manufacturer recognizable. and successful. So if Japanese car makers have mastered the art of designing concepts that are all about total fun, then take a look at one automaker that wrote the book on total performance. Everybody's heard of them. Mercedes-Benz. Founded in 1924, this legendary German car maker has always strived for high-end luxury and cutting-edge performance that keeps the driver in mind, especially in this car. You want something no one else can drive? Something just for you? Then hop into the strange-looking moonshot, the F300 Life Rocket. It may look like one of the most insensible cars you've ever seen, but what it's done for the technology of driving is invaluable. You're not seeing things. The suspension is turning into corners just like a skier on a slalom run. This very personal concept car was the study model for a brand new prototype that unveils a whole new way of looking at driving.
The future of the automobile you won't find in crystal balls like this. You'll find it in our F400 carving.
It's a head turner for sure. Check out how these doors open. Get in and take it for a spin. You'll feel like you're in a James Bond movie with open wheel wells and sports car styling that harkens back to another era. But where the rubber meets the road, this car is all about the future. In this animation, you can see that when the vehicle hits a corner, one side of the suspension folds into the curve, while the other stays perfectly aligned. It replicates a skier carving into a snowy hillside to take unbelievably sharp turns. The result of this technology? Let's just say if the car were an Olympic skier, it would be getting a gold medal for performance. There's no doubt concept car designers are making handling and horsepower a top priority. And Daimler Chrysler, the parent company of Mercedes-Benz, has shown the world it can cover the gamut of what drivers want in a vehicle, especially American drivers. Maybe you've thought about it. Lying on a beach, catching the ultimate wave. Well, travel here to Miami, Florida, to the trend-inventing South Beach, where models and beach bums meet to live the perfect lifestyle. But when you're cruising Ocean Drive on your way to soak up the sun, you just might be able to do it in this.
I like the wood panel because I like the woody.
It might look like the old-school wood cover station wagons that surfers made famous, but the Dodge Kahuna is all about present-day partying.
It's about people who want to get out, enjoy life, enjoy nature, and they don't want any boundaries between them and the rest of the world.
If you thought all car designers were just nerds with pocket protectors and a knack for numbers, you haven't met Jordan Meadows. He's one of a whole new breed of designers that's obsessed with making cars functional and fun.
Sitting on $3.5 million of a corporation's money right here, and there's nothing like it.
$3.5 million. But the designers needed that kind of cash flow to give consumers a look at the wave of the future.
It has a feel that is very California. And I think we're starting to see a little bit of that creeping back in with California leading design for the U.S. and bringing that back into the mainstream.
All the glass drops. You know, when you're in a minivan today, you're in this little cage. Here, there's no pillars. Check that out. Remember the cars in the 50s? Those old Woodies that everybody loved so much? Great materials. Here it's lace wood, aluminum, and it's real too. And that's classic American craftsmanship. It's not just cool on the outside, but we got some great functionality on the inside too. All of these seats drop down. They form a wave, which kind of keeps your luggage where it needs to be. Bungee cord holders, cup holders.
One look at the Kahuna, and you're gonna realize that concept cars are all about taking what you thought you knew about the driving experience and turning it on its ear.
What do you guys think? You like it? Yeah?
But why not present this car at an auto show, just like everyone else?
Problem with auto shows is you have a very isolated kind of environment where the car is static, it doesn't move, and people can't even touch it or experience it.
You can step right up to it. Yeah.
And when people touch a real vehicle in the real world, they've got a real opinion.
When people come up and talk about the car, I mean, that's really what it's all about. Concept cars are experimental.
It should be a four-wheel drive because you can take this right onto the beach and then dump your boards and go riding.
Yeah, this is all great to hear. I mean, you get good ideas.
Yeah.
The Kahuna designers definitely want to hear what you've got to say. But if you see the Kahuna on your street, remember.
No, don't do that.
Don't touch it.
This car is worth $3.5 million. Coming up, feel the intense torque with some of the most powerful prototypes you've ever seen. Also, concept cars are designed to let you take a peek into the future. But the automotive industry's ambition to show you what might be has a radical history too. Beginning with famed auto designer Harley Earl's Buick Y-Job, concept cars have always tried to show consumers the excitement in the possibilities of technology and design. The use of concept cars as a tool to demonstrate the future has resulted in hyperspeed advancements in style and technology. But concept cars are really about the bottom line, making you want to buy something even better than what you have in your garage right now. And today's concepts have more elegance, more style, and more muscle than you've ever dreamed. And auto designers are the brains behind the brawn. Today, a new generation of concept designers, like the ones at Daimler Chrysler, are leading the charge in making hot rods mainstream. Especially with this bulked up concept. It's called the Airflight, and it looks like it's straight out of a kid's comic book. Why?
I'd say the average age in the design office is probably about 33. It's pretty young for a design office, which is cool.
It's a modern version of Art Deco, if you want Neo-Deco. It's got the very streamlined, tight design, the use of speed lines on the hood, which is very much a Deco design theme. It uses the cool metals to give an ambiance to the interior.
It's very simple yet like futuristic, like everything about it.
But no matter how cutting edge this car is, with its long front end, snubbed back end, and rear wheel drive, the Airflight is still old school muscle car. Listen to that muffler for even 1 second, and you'll realize that this beefy machine is just one of a new breed of vehicle that is throwing out what you thought you knew about how a car should look and feel. The Dodge Razor, the Super 8 Hemi, the Chevy SS, the Chrysler Crossfire, all muscle, all the time. But what if your vehicle had so much power that it wasn't an engine on wheels, it was an engine with wheels?
I think, quite honestly, when it comes to crazy concepts, the Chrysler Tomahawk has got to be one of the craziest that have been around for a while.
500 horsepower and 2 wheels in front. The people that built it for Chrysler and Dodge did a magnificent job if you look at the workmanship and the detail in the vehicle itself.
If it looks like it's just one big motor, that's because it is. But you won't find this engine in even the most high-powered Harley. How many cylinders do you think this double-wheeled mean machine has? 4, 6, 8?
It has 10 cylinders. It's an 8-liter. It's the latest version of our Viper engine.
What powers this came out of this, the world-famous Dodge Viper. By this point, you may be asking yourself one question: why?
When you think about it, we're a car company. We don't do motorcycles. The fact that the 2 top guys gave it the green light says a lot about their vision and their ability to see that far ahead. It is a good investment for us. It's a good marketing tool.
It was created to get excitement for Dodge, and it did exactly that. And it really does that when you fire it up in the middle of a car show. Everybody comes running because they want to see what this 10-cylinder motorcycle is all about.
The design intent with this project was probably first and foremost to package this huge motor in a way that was aesthetically acceptable as well as ergonomically functional. And also the character of this motor being what it is, big brutal beast, I tried to let that come through in the lines and the shapes.
Most everything that's not motor is polished aluminum, even the wheels. But don't go calling the Dodge Tomahawk a motorcycle just yet.
It's technically not a bike because it has 4 wheels.
And those wheels are like nothing you've ever seen. Watch closely how each one leans independently into a curve. Now you might be wondering what kind of rubber those 4 hubs can lay out.
At 1,500 pounds, it will do 0 to 60 in 2.5 seconds. Theoretically, it tops out at about 300 miles an hour.
And with that kind of horsepower right at your fingertips, the Tomahawk is more than just unforgettable.
What it feels like to ride, all that power, comes on really quick actually, at will. And there's one word for it, and that's addictive. And anybody who doesn't understand why do something like this need only get on it and twist this.
Whether it's power, performance, or sheer innovation, concepts push the boundaries of imagination. And if you come here, to the hills of Pasadena, California, you'll find a place where it all begins, at the Art Center College of Design, a world-famous art school with an intensive design program. Designers start here when they're passionate about innovative automobiles.
I think I've seen some people cry. I think I cried once.
If you want to do automotive design, this is the most hardcore program that you can involve yourself in.
Generally, I'm here all the time. I don't really have a life anymore.
And in this serious design studio, students build prototype models just like the professionals. And their final projects end here, with scale-sized concept cars presented to the entire industry.
The translation between the paper and the actual 3D model it's kind of inspirational, I guess you would say.
But there's a lot to do between paper and glossy models like these. Hundreds of hours go into making just one of these innovative models. But the high-intensity program at Art Center has produced some of the most well-known designers today, including the person who designed the new Volkswagen Beetle, and the Ford 49 concept car, and this brand new Mustang.
I think there's no doubt that he's considered one of the finest designers in the world, along with another dozen.
I've been extremely lucky. A friend of mine, Ed Golden, says I have the fortunate attribute of always being able to fall up.
Legendary car designer Jay Mays also designed this car.
500 horsepower, 500 foot-pounds of torque, wrapped in a classic body shell that's arguably one of the most beautiful mid-engine cars of all time.
They displayed a show car, which was the Ford GT40. Once again, the public went crazy. They yelled in unison in Chicago and in Detroit and you name where, build it.
The people around the vehicle just kept telling us to build the car.
And they did. If you thought creating a scale model of a concept car was difficult, watch the time-lapse for the clay model of the GT40. Forget your everyday enamel paint. That polymer skin can be rubbed on, then adjusted to smooth out any imperfections. And if the final concept looks familiar, that's because it's a brand new version of a champion.
A car that's arguably the most famous Ford ever is the GT40 that won Le Mans in 66, 67, 68, and 69.
Race day at Le Mans.
And that was really important for the country. I mean, we were not only going to space at that point, we were going to take on the world of racing.
The candy-colored Fords are the fastest, with 6 of the top 10 starting positions.
After performance builder Enzo Ferrari rejected Henry Ford's attempt to purchase the Italian automaker, Ford Motor Company built its own high-performance car. And in 1969, at a record-breaking 217 miles per hour, the GT40 left every Ferrari it took on in the dust. This 4-time winner of one of the world's most famous races disappeared into automotive history until Jay Mays took the lead in convincing Ford to redesign the GT40 into a concept car, and now into a production vehicle.
We're reintroducing what is a vehicle that I simply think can't be improved upon, but we're putting modern mechanicals, modern safety, modern engineering, and putting it at a price, although very expensive, is in the world of supercars actually a bargain.
And what is a bargain for a supercar?
It's obviously going to be a vehicle that costs well over $100,000.
Mario Andretti equals that mark in his Ford Mark IV.
This car doesn't have a typical business plan. It was more for creating an image and an aura and recreating some history.
There's the checkered flag. It's an all-American win.
The GT40 may look like an old favorite, but it proves that designers who build concept cars can determine what you drive when you go to work or when you're on vacation. And as long as designers are thinking up innovative and exciting ways to let you travel where you want to go, the auto industry will continue to grow and change.
There aren't that many great automotive designers in the world. There's a handful, but those handful of designers usually have a team of very hungry young designers under them that are continuing to drive them forward and make them look for new solutions that are going to please customers. So kids coming out of school today have got to be obsessed with what I always call cutting the old man's knees off.
I want to create things that have a strong emotional impact on people in a positive way. Whatever it is, I want to create it hardcore.
I just would like to see my design out there. I'd like to see it affect somebody in some way, so that 50 years later, to somebody, it could be a classic.
Concept cars are the brains. In studios around the world, car makers design, test, and build just a handful of concept vehicles every year, like this Chevrolet SSR concept pickup truck. And here, at the GM Design Center in Warren, Michigan, state-of-the-art computer modeling allows designers to analyze and change designs in advanced environments like this, where life-size 3D computer models of concept cars can be studied even before they're built. But this secret design center isn't open for tours. In fact, they don't want you anywhere near the place.
There's a tremendous effort placed on confidentiality and secrecy in the marketplace because it's so competitive.
With billions of dollars in new car sales at stake each year, automakers are in constant battle for your loyalty. That's why the latest advancements in concept technology and design are treated with extra care.
The concepts are the crown jewels of the company in many ways, and you don't want them to know even what you're thinking, so you keep that locked down as tight as you can.
I think the secrecy is very, very important. It adds to the excitement.
And in this 18-wheeler, there's one vehicle that was kept so top secret, just a few engineers and designers even knew of its existence. It's a make of automobile that has always represented the finer things in life.
This car is destined to be a classic.
The whole car is about premium, the ultimate of everything.
Hear the name, see the logo, and two things come to mind: luxury and power. And Cadillac may be one of the best when it comes to its concept cars, especially with this.
I think the Cadillac 16 was an interesting and bold statement. It has some terrific styling cues to it, And it's gotten a tremendous amount of attention for Cadillac, which is exactly what they intended to do when they created it.
Very dramatic proportions, long hood, long wheelbase, big wheels, short overhangs. It's very wide and low.
Based on groundbreaking Cadillac concept cars from just a few years ago, like the innovative Evoque, the Cadillac 16 also gets its look from one car that's over 70 years old.
You can see various cues of this car from Cadillacs of the past.
Believe it or not, this is only one of 3 1931 convertible Cadillacs known to exist, and it was a major inspiration for the new version. On the outside, they may not seem alike, but take a look at this number, and take a look at this number, and take a look under this clamshell hood, and this clamshell hood, and the relationship is obvious.
Many people ask, why we did the 16-cylinder engine.
Not 8, not 10, not even 12, 16 cylinders. And if you take notice, then look a little closer. 1,000 horsepower makes this Cadillac engine one of the most potent power plants to ever come out of Detroit.
It's a legitimate 16-cylinder engine and not a copy or a cobbled-together piece.
And if you think this aluminum skin, glossy black thoroughbred is the ultimate on the exterior and under the hood, then you might want to take a look at the interior too.
Really, you're just swathed in wonderful materials like Tuscany leather, burl walnut everywhere, and a silk carpet that you hardly want to have your shoes touch. Really an exquisite place to be.
And if a genuine Bulgari clock doesn't make you drool, then take a closer look at the steering wheel and you'll know you're experiencing one of the finest concept vehicles ever built.
When you first sit in the car, you can't help but be taken by the crystal badge in the steering wheel.
How much would you pay for a piece of cut crystal like this? Try $8,000. It's just another one of the details in this car that's designed to make you believe one thing.
This is a car that's, just monumental in scale.
Concept cars are all about elegance, styling, power, and now this. Coming up. When you think about some of the most advanced concept automobiles, you probably think about performance, power, styling. But car makers aren't just working on how to do 0 to 60 in 4 seconds flat. They're also figuring out how to do the right thing.
Petrochemicals eventually, fossil fuels, are eventually going to start running out. We don't know when, but the experts agree that it's a finite amount and that eventually we will run out.
Since automobiles were first invented, people have been looking for alternatives to gasoline to get them from point A to point B. But what if the byproduct of you traveling across the country wasn't toxic exhaust, but something a whole lot better?
It's a zero-emissions hydrogen engine. Water drips out of the tailpipe. You could drink that water, it's so clean.
Fuel cells, like the ones found in the Toyota Fine S concept car, are changing the way people look at powering their vehicles.
This is Honda's hydrogen refueling station. It's a futuristic concept, and it's based on generating hydrogen from a renewable source, mainly sunlight. We take sunlight from the solar panels, we generate electricity. From the electricity, we break apart water into hydrogen and oxygen. And from the hydrogen, we store it in the station, and then we use that to fuel our fuel cell vehicle.
And it's not just sunlight that can make hydrogen. There are a variety of ways to produce this efficient fuel.
The method that's used prevalently today is to take natural gas, which is predominantly methane, and do what's called a steam shift reaction, where you add high-pressure water to the methane, and you get a lot of hydrogen coming off.
Once extracted, the hydrogen is contained in tanks. When you need to fuel, drive to a hydrogen service station and fill up just like gasoline. And why switch from gasoline to hydrogen?
The big advantages with hydrogen, number one, is you get up to 25% greater efficiency from a hydrogen internal combustion engine than you do from a gasoline internal combustion engine. The emissions are reduced 99% plus.
And now, Ford Motor Company has joined the revolution using this alternative power source in a brand new concept car.
The Model U is really a project that we did to have a very serious look at how cars are produced, the type of engines that they will need in the future.
The hydrogen-powered Model U is the latest in alternative power. But look closely at the stylized body, and you'll see something you won't find on any other vehicle. All the body panels are recyclable. But when you're done with the car, don't bother taking it down to your local plastics recycling plant.
It's all soy-based materials, both in the fenders, the seats, corn-based tires with very little carbon in them.
Even the rollaway canvas top looks good enough to eat. The Model U takes renewable resources in automobiles to a whole new level.
The entire car becomes cradle to cradle as opposed to cradle to grave car. And so it turns out to be an entire cycle of life that the car can go right back into the ground when we're finished with it. It's a very exciting concept and one actually that's quite realistic.
And it proves with new alternative power source vehicles like the Model U, concepts aren't just about creating the most opulent cars on the planet. They're also about saving the planet.
The car is as clean as a field of corn because it's actually made out of a field of corn.
It just goes to show you, you can have your dream car and eat it too. Coming up, the line between fantasy and reality is blurred. We'll see some of the concept cars may let you dream bigger than you've ever imagined about how you're going to travel in style. But what do the biggest auto manufacturers do when they want to drive their imaginations wild? They come here, to Zumikon, Switzerland. But if you thought this tiny European country was all about cuckoo clocks and cheese with holes in it, then you haven't traveled here, to Rinspeed, where concept builder Frank Rinderknecht has created a supercharged empire designing some of the most experimental concept cars ever built.
People considered me to be crazy, to be outrageous. They forecasted an end to come soon, either being broke or going out of business or whatever. And we're in the comfortable situation now that people are really almost expecting it and looking forward for next year what's to come up.
Rinspeed builds custom cars for wealthy individuals, but they also partner with manufacturers to experiment with new features and new concepts. And here may be one of the strangest you've driven. Ever come across that hard-to-find parking spot only to discover that it's just a little too small for your car? Rinspeed has a solution. It's no illusion. That car is getting smaller. It's called the Presto. And it's one of a stable of Rinspeed concept cars that push the limits of auto innovation.
A prototype should open a door to a vision, should open a door to what the future could bring, maybe in a different way, but made us think.
Like this. It may appear to be a high-speed sports car, but push a button, and this vehicle becomes something else altogether.
The Bedouin, a retractable roof to transform a station wagon basically into a pickup truck.
And the interior is as unusual as the outside. It's got a cowboy theme, a rawhide interior. Even the Western-looking seats spell out Rinspeed in rhinestones. It's just one of the features that has allowed the Swiss concept maker to lead the way in designing some of the most unusual multi-use cars you've ever seen.
I create the concept, and then I have a very good, very efficient team of designers and technicians, and the rest is teamwork.
And this team just might be crazy. Where's that yellow car going? It's heading toward a body of water. No, this isn't an amphibious vehicle, but what it does do will make you want to hit the sand right now.
people turn around and say, wow, what is this? Does it fly?
Just hit a button and a hoist lifts out another vehicle you might not expect to see on any beach, anywhere. It's not a jet ski. Get your motor blowing. It's your own personal hydrofoil. You may be asking yourself, what would drive a person to want to make concept cars like these for a living? The answer is simple.
Yeah, I'm curious and I want to see what I'm able to perform and what I'm able to do, and that keeps me going.
In the race to be the first, the fastest, the most stylish, car makers look to all sorts of places to experiment with their latest designs.
I think there's an uncanny resemblance about what our design team does and what a film director does. And when I talk about an emotional world, that's exactly what a film director is doing when they create a movie. So the emotional backdrop for a movie or the emotional backdrop for an automobile is essentially the same. I have automotive design friends that were in the auto industry and now work in the movie industry.
I didn't fit in very well in the car industry in terms of, my working style and what I wanted to, sort of where I was aspiring to go and what I was trying to do. I fit in a little better in the movie industry.
Nick Pugh builds cars for the movies. He also built this, the Xeno, a natural gas-powered jaw-dropper you won't see on any car lot. Take one look at this intergalactic-looking vehicle, and you may nod your head. Or you may shake your head. Either way, Nick Pugh doesn't really care.
It may not appeal to everybody, and it really isn't supposed to appeal to everybody. It's supposed to just appeal to one person, because each individual person's vision can be realized in a unique form. So it really represents the possibility of extreme individualism.
And this young designer has taken that extreme philosophy to the extreme. Would you believe he'll help you build your very own personal concept car?
I think that the most best comparison, or the most logical comparison, would be to that of a client and an architect. At the end of the first design phase part of the process, I would produce a finished digital rendering of what their car would look like with them standing next to it. And it's a photorealistic painting or illustration.
Nick's celebrity clientele includes film director Roman Coppola. Believe it or not, he's standing in front of a digital rendering, not a real car. His own personal sports limousine concept vehicle.
And it's a very sort of stealthy, quiet car, very almost like comes in at the end of the night and comes in like a shiny shadow and drops you off and then disappears into the night.
You can stay happy with the illustration, or if you have a few $100,000, Nick will finish off your vehicle just the way you like it.
It's like the process of coming up with something from nothing and having an idea in your head and then seeing it real and getting to use it is really very rewarding. It's very fun. And I would encourage people to look at that side of it rather than all the struggle and cost.
Concept cars are all about the advancement of performance, style, and technology. In fact, the future might just mean that anybody can design their own car from scratch. And some of these vehicles won't be built, they'll be grown. Whether it's traveling in tomorrow's super techno boxes, rolling down the highway in the newest style and performance, or getting behind the wheel of a retro futuristic power performer, there's little doubt that concept cars are built by people, for people who love dreaming about cars.
We're actually trying to tug on the heartstrings of the customers, and usually the ones that are the most successful are the ones that do that in probably the most emotional way.
The ones who make the money are the bold thinkers. They're the ones who go out there and say, you know what, I like this car. This car is important. It pushes all the buttons as far as we can tell. We're just going to build it. Those are the cars that inevitably, whether they're great successes in the number they sell, they're always the ones that you remember.
The best thing I can say for the car business is, thank goodness people care. If nobody cared what the next model looked like, if the love affair was gone, it'd be pretty dull around here.
Get a fourth job to get me the G35.
Yeah, we'll see.